Well, this is probably going to be pretty short, but oh, it might be long. It's covered all possible options there. A long time ago, as part of my university degree, I made this crazy app called she didn't really have a name. It was just this kind of research report that I did. And the first prototype was horrendous. It was this crazy, like, thing made with VRML. And it was pretty, like, sparse. So I added these, like, blue bits to make it more exciting. Basically, there's, like, a list of files in 3D for no other reason than we had to use VRML, and these kind of like 3D bars which represent changes. So green is obviously lines added and red is lines removed. But of course 3D kind of sucks for any kind of, well, for most visualizations it doesn't really add a lot. Only one extra dimension. Yeah, that's pretty horrendous. It doesn't even fit the whole visualization on the screen, so. So after a while I just mucked around with HTML and managed to come up with this. And I actually don't know if this was before GitHub made their profile green boxy thing or afterwards. I tried to figure it out. I think GitHub might have been like just a little bit earlier with this style of visualization. I'm sure they weren't the first person to invent it either, but this was a long time ago. Anyway, that code base was pretty horrendous, and it was just like this one script, Ruby script, and it was old. It was possibly some of the first Ruby I wrote, and so I quite like this visualization because it shows you a lot of information about clusters of work. So I rebuilt the tool over the weekend, and not all of it is completely rebuilt, just the core parts, the most important parts, I guess. And this is a visualization of Async, and so it starts from 2017, and each column here represents 1 week. Yeah, that's right. And the number in here is just the number of commits, and if you hover over, you can see the commit. Honestly, it's not really that useful, but it was kind of helpful for debugging, but it's not practically useful. And then you can see, so obviously there's quite a few of these between 2017 and now if it's weekly. But you can just generate like monthly or quarterly or yearly. The funny thing was I did this on one of my assignments, and you could clearly see that I did all my work in the 2 weeks before the assignment was due. It was like sporadic commits, you know, for a few months earlier, but so you can you can pull some interesting information out of these visualizations. So let's just do the monthly version. So git heatmap generate period monthly. And you can put more than one repository in there. So if I wanted to put like 2, I could do that. And then I'm just gonna, can I just do that? Will it work? No. So it's still basically the same date range, but these now represent months. And I guess one interesting thing you can spot right away is that Async IO didn't really start until 2 months after Async came into existence. And I suspect a lot of that is actually I/O related, and I thought this is a stupid idea to put I/O code in the core gem. It's possible, I can't actually remember. We could dig into it further. And so that eventually got split out into this. That's just a guess at what we're seeing here. But yeah, I think it's interesting you can at least see some things like that. And then you can see for like January, what was it? Oh no. October, November, December, and January, I was just like, screw this, I'm on holiday. Man, is the stream flickering like crazy? Yeah, it is a little bit. I don't know what random combination of settings fixes flickering. Surely NVIDIA could like sort their shit out. I mean, they must have enough money, right, to make X11 work. Oh, screw it. I apologize for the flickering. There's nothing I can do. Blame NVIDIA. So, what the problem with this visualization right now is that, so this one commit here, A93F, that's A93F. It's all the same commit, but what this means is that commit touched those 4 different directories. So the point is it shows you not just like commits, but what those commits actually were touching. In fact, you can kind of expand this a little bit by increasing the depth. So now we have like more granularity on the number of directories. So now you can see, for example, you know, when I was doing specific work on the async specs, and that's a more recent one that I've been playing around with. So now you can see like when the examples came into existence. There used to be a hovering feature that would highlight the rows, but it's been lost in the sands of time, so it's a little bit hard to find these correspondences, but anyway. So I wanted to actually do a live stream of the whole conversion of the old code to the new code because it's pretty fascinating. And it was a small enough project that I think I could have knocked it out. Actually, it took me all of today to do it and a little bit of last night. So it would have been like 10 hours of coding in total to bring that back from the dark ages of my university life. And the problem right now, as I mentioned, is that so these are individual commits, and a commit can be 1 line of code or it can be 1,000 lines of code. I mean, in theory, or even in practice, you shouldn't make 1,000 line commits. I guess you should break it up, but the magnitude calculation is a little bit wrong. And so there was actually in the original one, I had this magnitude function. It's got a few different iterations, but it tries to look at the total number of revisions, and then it looks at the lines added and the lines removed, and then it weights that all together to produce like a final kind of magnitude, and then it uses that for the color visualization. So like red, that's most extreme because that's 20. There's no other 20 commits in 1 week period. So, and we don't know, that could be 20 lines of code and that could be 200 lines of code, but it was 1 commit, so we just don't know. So we're going to fix that. And as part of fixing that, we'll just have a look through how this whole thing fits together because we'll have to touch most parts of it to figure it out. So this is not the first time I've written like a git command, like an extension command. I have another one called git timesheet, which it's a little bit older. I haven't worked in it for a long time. And that command that just produces like a kind of an estimation of like how much work you've done on a particular, and you can throw in multiple repositories, and it just kind of gives you an idea. On that day, you worked approximately like 1 hour or something. It's pretty, it kind of tries to join commits together to look at contiguous segments of work. And it was just a little bit of a hack, so I can sometimes figure out what my timesheets should look like if I've been hacking on something and forgotten to log it. And so these commands fundamentally, they're interacting with the Git database, either like a list of commits or the objects or something else. And in Ruby, we're really lucky to have this gem called Rugged. And Rugged is a really awesome gem. It basically gives you the full power of Git in Ruby. So you can just repo equals Rugged repository new path to my repository. And then you can do things like get the head, you can add content, you can make commits, you can read objects, you can add objects, all this kind of stuff. It's pretty awesome liking it. For the most part, it all works. It's a little bit of a complicated dependency to pull into a project because it has an extension which I've sometimes found a little bit flaky just because of libgit too. But it's pretty cool. One of the crazy project I made based on this is called Relaxo. It's a transactional document database built on top of Git. Wow, that logo is huge. So Relaxo is a document database for Ruby, but it's backed onto Git. So one of the cool things about that is you can like fork your database, or you can clone your database for backups, or just for replication. So it's pretty neat. You can do all sorts of anything you can do in Git, you can do with this database. I kind of feel like as a model for databases, it makes sense. I wish that sometimes with Postgres, like you could make tags or branches and stuff, and just if you stuff something up, you can roll back to a previous tag or something. It would be super awesome. So Relaxo lets you do this. So it's not great for like multi-gigabyte databases, but for like small apps where the data is more important than scalability, Relaxo is a pretty cool option. So that uses Rugged to interface with Git and store objects. So using Rugged is pretty straightforward. The main data structure we have in this code is called commits, and it just basically aggregates commits together for the purpose of the visualization. So this is the samovar command. So it's just like a command line subcommand, and so it has a bunch of options. You can specify template period, depth, output file, and then it takes a list of paths. There's a basic set of functions here for supporting the command line. So this just, if you specify hourly, daily, weekly, monthly, quarterly, or yearly, this just turns it into an actual object which implements that from this file called period.rb, and that just has these classes hourly, daily, weekly, monthly, quarterly, and so on. And they have a method called name, which gives you like a human readable name, and then they have this method called key, which given a time, it truncates that time to something which is considered daily. So if you give it like 5 p.m. on 2016, 1st of the 1st, at 5 p.m. it will truncate it down to the 1st of the 1st at midnight. And so all of these do this kind of time truncation. And because of that, you can use them as hash keys, which makes them really convenient for aggregations. So let's have a look at commits briefly and have a look at how that works. So commits takes a filter, which in this case by default is just weekly. In fact, these defaults are just totally arbitrary. And depth is 4, which means we're going to look at up to 4 directories deep. And anything deeper than that will just only be hashed on up to 4 directories deep. So that is how you control like the paths on the left-hand side. So like that's 2 paths deep. We collect a list of authors and then the directories. The directory is actually the truncated directory based on the depth, and we make an aggregate for all the commits. We store the depth, we store the earliest commit at the latest commit, so we have like a bounding range for the time, and there's like a cache for the maximum magnitude, or in this case it's the maximum number of commits, but we're going to change that. Then we have this method down here called add, and that takes in a rugged repository, which is a Git repository. We make a walker, which is going to walk over all commits in date order. We push in the current head, and then basically just go over all the commits and we add them into ourselves using that left shift operator. Over here, because maximum might become null, we just invalidate that cache. This was a little bit of a bug, I think, in Rugged. Rugged isn't the most perfect system. Sometimes the documentation is a little bit confusing, or I just may be wrong, but that's okay. It's an amazing tool, and so you can just work around those issues. So given a commit, we can get a diff. So a diff is like a list of everything that changed, and we need to diff against something. So in this case, we diff against the first parent. So most Git commits only have one parent, but a merge commit can have two. And because this tool is relatively straightforward, we just do it one. I guess you could make more than one diff, and you could run this code at multiple times, but I don't know if that would serve that much purpose. So we pull out the author. The author is actually the whole author, it contains the name, the time, the email, and all that kind of crap. So it's a little bit confusing. You kind of think you should say commit.time, but there's actually commit.committer as well, and that can be at a different time. So I guess it makes sense. We add that author into the author's hash. We update the timestamps, like the earliest and latest commit. Then we go we do this thing called diff.eachPatch, and a patch is it's actually like the number of lines that change, like what lines changed, and we have to get the patch.delta. I don't fully understand why I can't just get the pass out of this, but if we do this, the delta tells us the old file name, the new file name, and like any other changes that happen to the file. So we get the path. The path is the delta new file, which is a hash, and it contains a bunch of stuff, and we just want path. Then this is kind of the magic where we consider depth. So we split the path based on the file separator, get like a list of parts. Then we shift onto that path. So the very first thing becomes the directory name of the work directory of the Git repository, and what that allows us to do is, in this case, it lets us put async. So if you do like multiple repositories, you end up with the name of the repository. It's a little bit of a hack, but it's quite nice actually. I'm pretty okay with it. So then we remove the file name because we definitely don't want that, and then we truncate that to the maximum depth, and we add that into the list of directories. And this operator is actually hitting aggregate append commit. Now, I actually found that the walker sometimes walks over the same commit more than once. I don't quite understand why that's happening. So I have this bailout here, where if we've already looked at that commit, then just don't add it again. Then what we do is we just add that into our hash table. We've seen this commit. We pull out the author, the time, we truncate the key according to the filter. So this would be like weekly or monthly or whatever. So now we have a hash key for that week or month or year or whatever. And basically, if there wasn't any, if it was just a blank box, nothing there, then we default initialize to an array, and then we add the commit into that array. Then what we do is we update the maximum size cache, and this will have to change probably, and then we update the timestamps. Once we've got this data structure, the generate command, so what we do is we go commits equals commits.new, and the command line option self.period and the depth that the user provided. We go over all the paths, the many paths that could be provided. We discover the repository at that path using Rugged, and then we add all those commits into that data structure. Finally, we call template commits.call, and template commits actually just creates this thing called template series.new commits title self.title. Self.title is the concatenated, all of the path space names concatenated by a comma. So if you do actually generate a report for more than one repository, it will just end up with two things up there. Right, so this thing here is a template. It uses Trini. Trini is this crazy thing I made a long time ago. It was based on another gem, or was inspired by another gem called Remaze, which was a web framework by Manverer very late in 2012. And he made a template processing system that I quite liked. Let's just see if we can find it. I don't know if this still works. Last commit 2016. It was when Data Mapper was popular and people were just trying to experiment and figure out whether you could do something better than Rails. Gem file probably be listed. Oh no, hold on. Maybe this one. I think it's that. Yeah, this is the one. First version dates back to 2016. That is a long time ago. So I quite liked the fact this template was just super simple, or just looks almost like Ruby, because you have this hash expansion. And then it uses this evaluation, which the angle bracket question mark is actually a recognized XHTML or XML instruction sequence. So it's super like standard. It's way more standardized in a sense than ERB. And so I made Trini, which was kind of based on the same thing, but it included like a bunch of other stuff, like for processing markup, event-driven markup processing. So it looks really similar. You end up with these question mark R Ruby tags and then just interpolation using hash. And that just all gets compiled into Ruby. And it uses these Regal parsers, which are ridiculously fast. I mean, it's definitely not the slow part of this. So this is the parser for... Yeah, this is the template language parser. So it basically does emits an event stream, and we essentially there is this assembler which handles these event streams and basically generates code, and then that code is compiled into a Ruby function, so there's no interpolation, it's just straight Ruby code at that point. So you can't really make anything faster unless you literally bypass Ruby. And the results speak for themselves. So I guess this is a little bit old because it's a while since I did it, but so the markup parser, which is like loosely like HTML compliant, it's, well, Nokogiri is 2.5 times slower. And then if you compare it to ERB, like ERB is 15 times slower. I guess it's not like a hard thing to be faster than, but anyway. So that's some background on where this template comes from and how, why I think it's good and why I use it. So this is the template here, and there is, I was inspired by a talk at RubyConf Taiwan. There was a person who talked, I think from GitHub, who talked about making classes to represent templates, and I kind of thought, oh, that's kind of a cool idea, because then you end up with, you separate out the code from the view generation just a little bit more explicitly, and if you can do that, then I think it's easy to reason about what's going on, and test as well, actually. So this class called series, there is a class method called template, which basically just loads that file, template.trini. And so when you initialize this, one of the optional parameters is defaults to that template, and it just saves that in an instant variable. And then you provide the model, which is the list of commits, that commit aggregate, and also a title, because we can't infer that from the model we get. Then there's just a bunch of helpers, like a ramp calculation, interpolation, this temperature function, which basically calculates the temperature, hex color, and this background function, background color thing. So finally, you just invoke call, and it goes template to string self, and so self is injected into the template, so you can write something like commits.each directory, and that will hit that commits attribute. So I quite like this. Like, I think it's pretty nice to do stuff like this. And yeah, I have to say I was pretty much inspired in this structure, because before I used to just dump code into this template, and after a while you start realizing it's a pretty bad approach for obvious reasons, I hope. So this template, basically it was a little bit tricky to get what I wanted in the visualization. I wanted to be able to scroll this part and have the list of directories stay on the screen. And when I made this in 2012, CSS was definitely not as advanced as it is today. So I used two lists. So there's a list here and a list here, and they just, the list items have the same height, so they basically match, they look like they match up, but one of them is marked with overflow auto or something, so it can scroll, and the other isn't. They're probably with Flexbox and more advanced CSS is something better now, but actually I did use Flexbox. I did modernize the CSS a little bit, but pretty much as it was in 2012. So let's have a look. We basically go over all the directories, and we go directory.join /, which produces this list here, and then we go over every period with the index. And this one makes a single list item. It's that list along the top, the grey one with the numbers in it. It's just index +1. Then we basically go over all the commits, each directory. We have the directory in the aggregate, and then we go over all the periods. And if there were any commits in that period, then we get the size, and so we make the box. And the background color is this helper method, which takes in the list of the size, the number of commits, and that figures out what color it should be. And we also put size in the box, like the number itself. And the title, which is the tooltip, becomes the list of period commits.collect OID join comma. And if there were no commits, then it's just this div, which is empty box, which is exactly the same as all the other ones. So there's a whole bunch of like empty boxes except for where there's commits. Yeah, so I guess, yeah, the problem right now is that we just need to like basically change this line of code. Essentially, we want something that better reflects the impact of those commits in that directory. So it could be that even though this is the same commit in 4 different directories, there might have been a ton of code in here, very little code in here, almost nothing in there, and maybe a little bit in there. And so we should weight those 4 boxes accordingly, and that's what we're going to hack on today. So one of the complicated parts of any kind of color scale is that we essentially need to know the minimum and maximum. And I guess the minimum in this case is 0 because you can't have negative lines affected. But the maximum certainly is a little bit tricky to keep track of. And so that's why we have this cache here. And we basically just go, so right now it's just commits.size, but we need to make that something else, I guess. And what we are interested in is actually the magnitude of those commits with respect to the directory this aggregate is for, and we might have to modify this code down here. So I think patch contains additions and removals. Let's have a quick look at what's going on there. Okay, so patch, yeah, I love it when it's a C extension. Okay, so we have additions, that's lines added, and deletions, it's lines removed. So we're going to add that commit, but we actually know at this point it's not just that commit, but we also know the additions and removals, which we need to store somehow. So I guess I'm not sure if we care about the fact that it's related or not. But yeah, let's just do this to start with. Add commit patch. So that should be sufficient. Now I wonder if there's any chance we end up with the patch is per file. So you could have multiple files in the same directory, especially that it's getting truncated. So this can be called multiple times for the same root. So I guess we just need to keep that in mind. Add commit patch. Oh, that's probably why commit was getting called twice. That's interesting. Well, it doesn't actually matter that much now, I guess. At least not for that part of the code, because we still need to run this. So we only add the commit into the periods, like into one of these boxes once, because of line 53 there. But we need to we actually need, it's not just in general for because the aggregate is one whole row in this visualization. We actually need, it's per column. So we actually need another class to store all of this stuff. Maybe I should just call it literally row and column, but I guess it's confusing. Yeah, naming stuff is super difficult. I'm just looking at how it's being used. You know, we can probably just get away with this. Could be a bit of a stupid way of doing it, but let's see what happens. So we need the key because we're going to reuse it. And we're going to go additions, key, or equals 0. Actually, let's just make these. Hash key equals 0. Oh, it's not removals, deletions. Try and be consistent. So for the key, which is a column of a given aggregate, which is a row, so it's specifically one box, we can track, we can add patch.additions and then I guess so we'll just save that. If so, like churn is equal. I feel like it's not really necessary, but yeah. If churn bigger than maximum, so I wonder if that is enough, because the rest of that should just keep on working the same way. I don't know, I guess we'll find out. Okay, awesome. Nothing worked. What did I do wrong? This seems weird. Okay. Okay, now I need to actually choose the right number. So we have the aggregate. Let's save that as well. That might work. Okay, that's way more exciting. 5,508. That seems like a lot of source code. And why is that red even though it's only 3,000? What is going on there? A93F. Let's have a look at what that commit actually is. So there was that. $746 lines. So what happened? The OIDs is not that useful. Maybe what we can, let's just add in front of it. Aggregate. So we plus that many lines and minus that many lines. Let's see if that clears up what's going on. So it looks right. Hold on. Did we get something backwards? +0 minus 692. That seems super weird. We're definitely adding source code, not removing it. So something has gone horribly wrong. I don't know what. Okay, that looks okay. That looks okay. Okay, let's have a look. So we have 704. What is going on? I'm happy with how all that code looks. I just don't understand why we're getting 187. Let's jump over to that bit and have a look. I wonder how that's being computed. Additions, deletions, churn. That seems totally fine to me. That seems fine. That seems a bit weird. $20 and $4. What am I stuffing up? Maybe this weird syntax is doing something I don't expect. Aggregating the totals is stupid. That is not. I was assuming. Yeah, I was just confused with my own code. A common problem in programming. Additions and deletions were the totals after the addition. I think this should sort the problem out. So we actually don't need those variables. It was confusing to do it that way. Excellent. Okay, hopefully. Okay, that's more like it. 692. But why is it removals? We got the right number, but it's in the wrong place. I don't know how that's even possible. Additions, deletions. It looks like it should be a template issue, but that looks correct to me. What am I stuffing up? Are there any, oh yes, some of them did work. Well, something worked. It's just for that first one, it's completely backwards. And the other ones could all be backwards as well, but maybe the diff is backwards. Maybe the delta is actually computing it in the wrong direction. Because that seems like the only thing I can think of. Git commit parents first. What was it? Tree. Did I stuff something up? I saved that. It should be regenerated. Let's break on that specific commit and have a look at what's going on. If was it A93F, A93F. So that, I think, should be impossible because this is the first commit. So unless that's doing something strange. Maybe that's right, and we actually need we need to use like a null. There's something called like a null tree. Tree.empty. Okay, so hold on. This is a bit confusing. Let's have a look at the diff that's being produced. There is a way to format this as a string. Files, additions, and deletions. There should be no parent, so it should definitely be. I think this is just. I think it's backwards. I think the diff is backwards. Maybe the walk because we're walking it backwards. It's super confusing. Okay, so let's just make an empty tree. And I think we can do a diff on 2 trees. Okay, I guess it's backwards because that produces 127 lines added, which is kind of what we're expecting. Okay, well, if that's what it is, then we need to do this differently. And that should be okay because we use the parent, which should produce. You probably double check it and see. Okay, that looks way better. I think it's quite funny it worked in reverse. It's kind of like a pretty weird bug. Okay, great. 162 lines added, 0 removed. That makes sense for a first commit. I think the color is pretty whack. And I'm not quite sure why. It's because the curve, is something wrong with the curve. It doesn't really seem like there's like between 146 and 1300 there's not much difference. It just looks like the same red. So the maximum is probably wrong. So firstly, the maximum of a given aggregate relates to the churn maximum. Because in this case, churn will be like 1300. So that probably is okay. How about commits? Let's just okay, so now we're going to go 187. Okay, the maximum is definitely not 187. Okay, that just seems really wrong. 187. Where is that coming from? 187. So it should be that one. Where's 129 coming from? It's definitely not that. If churn is bigger than maximum, maximum equals churn. Directories. Okay, right. So the churn is 690. Well, the value there is 692. So I don't understand. Oh, hold on. Now this is where it gets confusing. We actually want the total churn, not just the churn of the last patch. Okay, oh, that's looking much better. So I guess in my original research, which I have to admit wasn't the greatest, I love how I wrote, this is the expansion factor. It changes how compressed the data is. This number is a bit magic. It will change the entire visualization. The lower this number, the more compressed the data will be. Yeah, it looks like I was trying to do some kind of logarithmic curve. Why would have I done that? I guess to try and I guess to squeeze stuff in a bit. At this point, we're just looking at the number of lines changed rather than the number of commits. In fact, this no longer takes into account the number of commits, except of course where there is a commit, a line is changed. Probably that's the most logical thing because it kind of tells you, this is telling you directly like churn, like the number of lines. So to me, when you look at this now, you go, oh, 249 lines of code changed. That's quite a useful metric. Okay, let's have a quick look at, I did notice in here, yeah, I might play around with the maths a little bit more, but I think that's good. Like we've done what we set out to do, and it is working. So I'm happy with that. And look, while we're here, let's just do an interesting visualization of a bunch of different stuff. What else? Maybe that's enough. Let's try that. I did this before and it's like, error, the path name is too long. I find it hilarious. My computer has like terabytes of storage and gigabytes of memory and more than enough CPU cores. And the file name is too long and it's 3 lines. I mean, seriously? Yeah, I don't know. Maybe I just shouldn't be surprised anymore by anything. Let's do monthly, otherwise it's going to just be huge. So this is an interesting visualization because it shows a bunch of interesting, it shows a bunch of developments which I think are pretty cool. So if you read the motivation section in the README for Async, I think I talk about Ruby DNS. It was like the first thing I started hacking on that had anything to do with servers and I/O and concurrency, and I think the straw that broke the camel's back for me was when I tried to integrate Ruby DNS with Wikipedia, and I just realized that there was no easy way to fit an event machine event loop with fetching a web page. I was just like, this is ridiculous. There's got to be like a better way of having a non-blocking DNS server that can fetch web pages as part of its job. So that started in this visualization is starting from 2009, late 2009, and these are full months. So I did a bit of hacking. I probably had some fun and some more hacking, and eventually I noticed this actually. You know, if R started. Should we have like a tooltip for the date? But I don't. 2011 or some thereabouts. $7,000 lines of code. There was the libev, and then for the actual source code was a bit less crazy. And that's had pretty decent, like, you know, it's been worked on a lot and it's been well maintained. You know, it's pretty continuous section of the visualization. So RubyDNS is being worked on, but about here, it turned into Async DNS. And you'll see that there's been a little bit of work done on it, but I think most of it now is pretty... So this is Async DNS, and Async DNS was actually a fork, like of celluloid DNS, which is why there's like a bunch of like early work, and it shows up in this directory called Async DNS lib celluloid, because it was originally celluloid DNS, and eventually I ripped it to pieces and rewrote it. So it looks like that kind of happened around there, because there's 1,400 removals and 1,400 additions. And it went from the celluloid directory to the async directory. And I'm guessing around that time RubyDNS started to peter out. Probably most of this work was just making RubyDNS, moving all that code into async DNS and writing the appropriate bridges so that it would just keep on working. RubyDNS still works, like it's still perfectly stable. In fact, it's been rock solid and stable for a long time now. So this is why I like this visualization, because you can see what's going on, and it helps you understand like where things are happening and what's going on. So around this time, I guess, async started happening. So you can see at the same time, I was super frustrated with celluloid just being buggy, and basically, I guess celluloid sort of worked itself into a corner with regards to there were just bugs that were impossible to fix, because in a different perspective they were features, and different code depended on different bugs in celluloid, and it just, I don't know, just at that point it's just like, you know, there's no like solution to this. Everyone's going to be disappointed if we trash everything that exists and try and start from scratch, and no one was kind of willing to invest that time either, I guess. Neither for myself, because it's kind of like, you know, I'm just going to be like solving all these problems and making more problems for other people by fixing these bugs that actually other people were relying on. So around this time, RubyDNS was moved into async DNS. Celluloid was folded up, and work began proper on async. So you can see async lib async, so that's the Ruby code there. And I guess that's been pretty solid since, when was that? 2017, January. I hope that's day month. Yeah, it must be day month. Day month. What? Oh yeah, month, day, year. Why would I format it like that? That's atrocious. I have to fix that. Right, so, you know, it's been since around 2017. It's been pretty stable. And then you see sort of the other projects kind of come into existence, like Async, Actor, Async Await, which has been sort of maintained, but it's kind of a bit of a joke. Async Container, which is really important for Falcon, so that kind of receives a lot of work, because as we add support for graceful restarts and supervisors and rolling restarts, the containerization of that across multiple processes or threads is really critical. Async HTTP is probably where I spent a lot of my time recently. You can see, let's have a look, async. It looks like Falcon was actually at one point going to be part of. That doesn't make sense. I'm having trouble lining these columns up because in my infinite wisdom I decided to remove the JavaScript, which did it. You know what, let's just edit the CSS and fix that. I was going to try and It's a list item. I think we want Heatmap. Maybe that's enough to do it. Oh yeah, that's good. That's a bit better. Oh no, oh no. Did it all just disappear? Oh no, we're just looking at the wrong place. Scrolling on this huge visualization is truly horrible as well. It needs a scroll bar that just stays on the page. I don't know. HTML. Right, so let's have a look. Where were we? Async HTTP. I don't know why that thing is not long enough. That is very funny. Anyway, it's enough for now. Okay, right. So async lib Falcon. Okay, so Falcon was originally I kind of must have hacked it into async HTTP, but it probably got removed into its own gem around that time. Where's Falcon? You see Falcon kind of, that's Falcon there. It kind of started off around the same time. Probably thought it was a really bad idea to put all those gems together and has seen continuous work since then. So that makes sense. So async HTTP lib async. So this is all the HTTP implementation code. And at some point I decided it was a bad idea to try and implement all the protocols in that one gem. It probably was around here, I'm going to guess, because it's got 1700 removals. And I started working on these gems called protocol-HTTP1. It might have been a few, it looks like it's a little bit later. Here, this is protocol HPAC, which is a fork of the HPAC gem with bug fixes and more tests. Protocol HTTP, which is a shared library of HTTP abstractions. And then, oh yeah, it looks like actually quite a bit later. This is protocol HTTP1 and oh, I know what happened. Originally, protocol-HTTP contained all the HTTP 1 and 2 implementations, but I got to a certain point and decided that was a bad idea because HTTP 2 was such a monster. And so probably that and that minus 3,400 lines of code, and that probably 3,400 lines of code became that, which is HTTP2, which is 2,400 lines of code, and HTTP1, 840 lines of code. So that split up there as well. So that gem was originally containing both those codes and split up. That's quite a recent, in the last 5 months, so 5 months ago, I guess. This seems pretty recent. So yeah, I think this visualization is pretty cool. I guess you still need to know what happened and when and why. Async WebSocket's pretty recent. Async Redis is pretty recent. So, as async itself has sort of stabilized, can we see that it's stabilized in this data? I don't know if we can. Async, lib, async. I think you could say that there was a lot of work done early on. You can see it's pretty busy there, busy, but in the last couple of months, it hasn't been that much. Like 90 lines of code, churn is not really a huge amount. So I would say as this code is stabilized, and then you see other things like async Redis, async WebSockets, this is all getting more attention and more focus. So yeah, it's a pretty cool tool. I'll publish these changes so you can make your own visualizations, and feel free to share them with me because I find this stuff really cool. And I'll try and fix the CSS as well. It's pretty crummy. Anyway, let's call it a day, and hope that was enjoyable, and see everyone again soon, hopefully.